Tann Corporation, an important part of Detroit's industrial scene. Founded in 1916 by William Tann, the company he called Congress Tool and Die has since expanded into the die casting field. The Congress Drives division becoming the world's largest producer of die cast pulleys. The Congress Tool and Die division strengthening its position as one of the nation's foremost producers of precision dies. Inside this giant plant on Detroit's Denton Avenue, American industry finds an indispensable partner, skilled craftsmen and advanced methods turning out tools of mass production. Orders for dies, special tools, and special machinery are processed by the experienced administrative staff. The needs of each customer are different, each requiring individual treatment. The estimating department evaluates the customer's specifications. Considering the size, quantity, materials, and the time required to do the job, costs are estimated and submitted to the customer for approval. Any special problems the customer might have are worked out by top-flight engineers. The engineering department also sets up production procedures, drawing up detailed blueprints from which the plant's tool and die makers will work. Inside the shop, precision equipment stands ready to turn raw metal into finished dies. Some of the large presses nearly touch the 42-foot ceiling, their tremendous weight held rigid by 14-foot foundations. Machines both large and small perform amazing feats, shaping sheet metal under hundreds of tons of pressure, achieving intricate shapes and forms through precision drilling, boring, and milling operations, duplicating contours exactly with delicately balanced cutting tools. Skilled craftsmen and carefully engineered machinery rise to the demands of every customer order. Before production begins on a die, a full-scale model is made of the part the die will manufacture. This master model must be exact, for it will be used throughout production to check the accuracy of the die. Careful measurement of the model makes sure the shape, flanges, and trim lines are absolutely correct. The die shoe is the basic building block in the construction of a die. Usually made of cast iron and varying in size according to specification, it's carefully marked so that machining operations will be performed in the right places. An upper and lower shoe is machined for each die. Other castings and steels will be placed between them to form the inside contours of the part to be manufactured by the die. Now the die shoe moves on through a series of machining operations. George Tann, son of the founder and vice president and general manager of the tool and die plant, takes an active interest in production details. His close personal supervision has given Tann Corporation customers confidence that high standards are being followed. To maintain those high standards, special cutter grinders and sharpeners are used to keep vital cutting tools in top condition at all times. Machines such as the small shaper form the intricate lines of the many small blocks that make up a die. These blocks, called die steels, fit inside the upper and lower die shoes to form the inner contours of the part the die manufactures. The hydraulic shaper, also used to form die steels, operates in the same manner as the small shaper, except that it handles much larger pieces of steel or cast iron. The various shapers perform rough machining, but the vertical milling machine goes a step farther, creating more intricate shapes in die steels. Further refinement is achieved by the surface grinder, which can shave the steel to tolerances of less than 1/10,000th of an inch. Extremely close tolerances are also achieved by the internal grinder in machining the inside diameter of round parts. Precision lathes turn soft steel to specified lengths and diameters. The jig borer is capable of maintaining a relationship of 1/10,000th of an inch between two cavities. In the final machining operation, the towering Keller produces tolerances as accurate as any mechanical device could possibly produce. The Keller operation is semi-automatic. At the top of the machine, a sensitive tracer scans a plastic pattern of the master model. At the bottom, the cutting tool receives transmissions from the tracer. These transmissions guide the cutting tool over the surface of the die block, producing the very same convolutions in the raw metal that the tracer is scanning on the plaster pattern at the top of the machine. A truly remarkable device, the Keller adds utmost speed and accuracy to die making. Machines have done all they can in this precision work. Now, skilled men take over to apply the finishing touches. Hand finishing or barbering is painstaking work, but only the human hand can bring the surface variations down to within a few thousandths of an inch. Another team of trained craftsmen called punch finishers apply their years of experience, their highly developed sense of touch to further refinement of the die surface. Careful measurement assures correct dimensions. Punch finishers use files, stones, and emery cloth to polish the die surfaces to an extremely smooth and accurate degree. Pride of workmanship is apparent in the workman's close attention to detail. The final accuracy of the die rests in their sensitive hands. The finished die must now be tested in a press, exactly like the ones the customer will use in the manufacture of his product. In this tryout operation, the die actually stamps out the part for which it was made. The stamped part is carefully compared to the master model to make sure each contour, each dimension, meets specifications precisely. Frequently, after an acceptable part has been made, irregular surfaces must be flame hardened with an acetylene torch. The surface to be hardened is heated to more than 1,500 degrees Fahrenheit, then quenched immediately in water, hardening the steel or iron to approximately 1/16 of an inch below the surface. Many Congress dies are equipped with time-saving automatic loading and unloading devices. The end products of the work carried on at Congress Tool and Die Division are quality dies that allow American industry to perform mass production, that make it possible to turn out as many as 700 large parts every hour. As the need arises for new types of dies, Tann Corporation will fill that need, as it has for more than 40 years, using its wide engineering and production skills to serve industry. The manufacture of die castings entered the Tann family of operations in 1930. Today, engineers plan the production through die casting of parts for many of the nation's most famous automobiles, home appliances, hardware, photographic equipment, and scores of other products. The making of a die-cast die is just as painstaking as the making of a stamping die, requiring all the dexterity of trained craftsmen and the speed, the accuracy of precision tools. But die casting is different from die stamping, in that parts are formed from molten metal being forced into the die under great pressure. Zinc alloy is melted in the foundry and transported to the die casting machines, where it's held at constant temperatures. Operated by one man, this versatile machine forces the molten metal into the die, closes, locks, then unlocks and opens the die. When removed from the die, the casting is quenched in water which cools it and stabilizes the dimensional requirements. The rough casting is sent down a slide to the trim die, which removes excess metal and separates the casting from the gate, the part that guided the metal into the die. Scrap metal is forced through the trim die and sent to a furnace for remelting, leaving the die clean for the next casting to be trimmed. The trimmed parts move along a conveyor for further finishing. They arrive at the automatic straight-line polishing and buffing machine, where they'll acquire a high luster before being plated. The parts move through the machine without stop, a graphic illustration of the modern methods used throughout the Congress Drives division. Conveyors do all the carrying, moving the parts from one station to the next, maintaining a steady pace so that production schedules are easily met. Alert workers place the parts on an overhead moving rack. The rack will carry them through a giant washing machine where they'll receive a thorough final cleaning before the plating operations begin. Two modern plating machines impart the durability of strong metal coatings to the surfaces of various parts. A complex mechanism moves the parts toward the plating bath. Coated first with copper, the parts remain in the tank long enough to gather the right thickness to meet the customer's requirements. The entire plating operation is fully automatic. After emerging from the copper tank through a water rinse, the parts receive a coating of nickel plate, again remaining in the tank until the proper thickness has been attained. The final coating is chrome, forming a protective film over the nickel and providing the high luster and easy-to-clean surfaces we enjoy on so many useful products. Transferred to a conveyor, the plated parts move on for packaging. In the modern plant laboratory, experienced technicians make constant microscopic checks of plated parts to make sure high standards are being met. Studs are now inserted so the part can be attached to the product for which it was made. Another modern machine applies the nameplate quickly and securely. The dependable conveyor transports the finished parts to the packing department, where they're placed in sturdy boxes for shipment to the customer. The care of packing department personnel and the quality of packing materials assures safety for the plated parts until they reach their destination. Some parts, such as automobile instrument panels, are painted rather than plated. When painting is specified, the studs are inserted first. In the paint department, the parts are racked for movement through the cleaning machine, after which they pass through a special oven to undergo a process called bonderizing. When the parts emerge from the bonderizing oven, their surfaces have been etched to promote better paint adhesion. The first coat of paint covers the open pores of the zinc alloy. The paint is applied by an electrostatic automatic spray gun in a continuous operation that cuts time and adds to efficiency. The color coat is applied in the same way, quickly, easily, smoothly, and economically. The very newest method of spray painting used to give Congress die-cast parts a handsome, corrosion-resistant finish. When two colors are required, as on instrument panels for proper light reflection, the coating on the back is applied by hand, with masking tape protecting the front of the panel. After a final inspection, the painted parts are packed. Congress pulleys, sold throughout the world by Congress Drives Division, are carefully trimmed to remove the gate and excess metal between the spokes. Further trimming is done on the skiving machine. Inside this automatic machine, the pulleys rotate while the table revolves, passing cutters and sanding belts that remove excess metal and smooth out the surface so that drive belts will ride easily when used with the pulley. Now the pulleys are automatically drilled, tapped, and bored on a machine designed and built, along with the skiving machine, by the engineers and skilled craftsmen of the Congress Tool and Die and Congress Die Casting divisions of Tann Corporation. Very often, the company must build special machines for specific jobs, machines that will meet a customer's specification for unique design. In both engineering and craftsmanship, the company's skill and experience enables it to meet any unusual requirement. The automobile industry especially constantly comes up with improved designs, demanding new methods in casting, trimming, finishing, in all operations related to die casting. Modern methods are used right up through the final inspection and packing of all parts. In homes all over America, Tann Corporation products are doing useful jobs. Parts for washing machines and clothes dryers assure efficiency on wash day. An attic fan or a part in a furnace helps keep us comfortable in all seasons. In the family automobile, the horn, the instrument panel, a door handle, a window regulator, or the ornamental trim was probably made at the Congress Die Casting Division. The management of Congress Die Casting Division has progressed with the times. Stuart Chosid, Director of Sales, and Executive Vice President David Tann, President Herman Tann, and Vice President in charge of Research Irvin Tann, along with George Tann, Vice President and General Manager of the Tool and Die Division, have through the years gone beyond the normal bounds of industrial management to fulfill the earliest dreams of the founders of Tann Corporation.